Morning, Tyler. Okay. Mr. Garrett, you there?
Yeah,
Can you when do you think you'll have chapter 2 homework done by?
I just submitted it. I didn't do the greatest, but I just submitted it.
Okay. Do you think you could study up and take the quiz tonight at some point from home?
Yeah, should be able to.
All right. I will let me see here. Just give me 1 second. Just so we don't have to just so we can have everybody caught up by tomorrow.
Yeah.
What's a good time tonight for you to take the quiz?
I don't have a clue. I mean, I could.
Just pick a time. Whatever's good for you.
6.
6 p.m. All right, so you have to take it tonight between 6 and 7.
Okay.
And just let me know if something comes up and you need to change that time.
All right.
Okay. Justin,
Yes, sir.
I'm assuming you're talking about Lab 4B, correct?
Yeah, the one you guys did on Thursday.
That has the control relay coil wired in?
Yep.
Okie dokie.
Yeah, I mean, I don't know. I just can't seem to figure it out. Like when I plug it up, my green light on the what you call that, the ice cube, was that the ice cube relay, I think.
Mm-hmm.
I can get that's lighting up, but I'm not getting the coils to energize. Like I don't know. I'm not getting that.
Okay, so when you press the green start button, does the light turn on?
Well, we don't have the green start button on ours.
What?
Our start button isn't green. We have the little push button.
Oh, in your
Yeah, we don't.
little package
Yeah, we
here,
don't have the big.
you got little green things, yellow things, blue things. They just poke right on top of there.
Well, let me see.
See what I'm saying? I just made mine green because I'm weird. All right.
Oh, we just stick them on top of our push button. Okay, I got you.
They just pop on there. All right, so let's look at this diagram real quick together.
Which one is it?
This is 4B. I have it up on the screen. Can you see my screen?
Yeah, I was looking at something else. I can see it now.
Okay. So let's go over wire numbers first. What wire number is this?
Hold on, I gotta move this thing.
That's 1.
It's a 1.
Yep.
What wire numbers are these?
All right.
That's 2.
2. 2. What wire number is this?
3.
3. And these?
Quattro.
All right. So on my trainer right now, I don't have this rigged up yet, but I can do it. And remember, I'll pick a different color. So here's what I'm doing if I'm you guys. And if I'm me, this is just what I do if I'm wiring something up. I put the little check marks. Remember you guys, remember me telling you how to do that?
Mhm.
I'll switch colors to like blue so you can see it. So I need to look at my stop push button and see if there's a 1. And my stop push button is these purple wires. So I have this coming from the power supply, plus 24 going over to my stop. So that's wire number 1. I'm not going to wire mine to save time, but I want you guys to wire yours to get in the habit of doing it. So wire number 1, I'm good. So this wire from the stop over to the start, that would be the other side of the stop coming down to my start push button. So that wire's in there.
I have that.
From the other side of my start, which is this wire, I need to go 1 up to the pilot light. And I have that. And I also need another one that goes over to the coil. So let me put, where'd my mouse go? I've got this one done and this one done. I also need a 4 to go to the control relay coil. So where's the control relay coil on this here schmear? Where's my control relay?
Ice cube.
Right here, right? That's what we're using for control relay.
Yep.
So on this thing,
Oh, I did something wrong.
13 and 14.
yeah, you got to look on here.
You got to work on your production value. That is just.
I'm trying, Nick. Damn it.
Oh,
All right. Where's the coil?
13 and 14.
Yep. Right. This little rectangle is what the coil is, right? So between 13 and 14, that's how we're going to energize the coil. This little diode with the symbol there, that's the LED that tells you that it's on. All right.
Yep.
So on the thing, all I need to do, so it looks like I have mine wired up to the, for the lab 3. All I need to do is get a wire number 4, either from the start push button or from the pilot light. So what does that mean? Can I pull I got to get to here, right? Can I pull a wire from here or here, or does it matter?
You probably want to pull it from the breadboard.
Why?
Because
Well,
it goes to the push button.
Because it's easier?
Yeah. Yeah, because you all your connectors at the or all your connections at the top across that are all used up either by the selector switch or proc switch or something else.
Well, I guess my point is it doesn't matter where I get it from,
Right.
if I have space to get it from there. The only things you'd consider, so if this is real life, I mean, this is not a real life setup, right? This is just a trainer. But
Right.
if you're down at CAT, right, this green pilot light might be in a different building than this push button, you know? So whatever's closest is the easiest thing that you're going to think about. But here, this is easier because it's just a stab in. But this wire going up here, this wire here, this is wire number 4. So anytime this green push button lights up, which I'm going to show you in blue here, anytime that lights up, that's because this is closed, right? So any wire number 4 is going to energize at the same time. That's really messy, but
Okay.
crap. I don't want to save that. The point is that all the wire number 4s are going to energize at the same time. So it does not matter where you pull it from. The only thing on here is you might want to be cognizant of how much wire you're using up, but you guys should have plenty for the whole semester. So I'm going to come from here because it's just easy to stab it in there. So I've got that. So now I have made this a wire number 4. I'm going to go into my C channel and 13 and 14 on here. I'm going to have to get my face real close to see it, but I'm just going to use this. So 13 and 14 on here are the bottom 2, if you're on the side of the red DIN rail tab, these 2 screws, 13 and 14. So I'm going to go to one of them with this wire number 4. So before I move on, and what I've done is put that wire here. Crap. This, I just did this wire number 4, right? So this is done. I've put a wire number on it, so that's number 4. This 2 from the pilot light is already made up right here. Remember we had all those pilot lights tied together in our negative side? So that's already done. I just need the negative side of the coil. So I need a black wire to go where?
To the black terminal strip.
Right, so I take number 14 black wire over to the terminal strip. And that's what I gotta do. So I'm gonna do it right now. I don't care what you say, I'm doing it.
Why don't you do that?
Nick, just go to sleep.
I so want to. The terminal block, what manufacturer terminal blocks are those, or are they just generic?
Remember the name, hang on, I'll tell you. All right. Once I've done that, I can go to my ladder diagram and I can say, all right, I got the negative side of the coil done. Looks like I'm all set. So if I energize this thing, what's going to happen if I push that green push button? If I close this,
So the light should light up and the switch should connect.
and the coil will energize,
Yeah.
right? All we're doing is energizing the coil. Now internally in that relay,
You're gonna hear a click.
you should hear a click, and all that is all the other pins are changing state. So all the normally closed contacts are becoming open, and all the normally open contacts are becoming closed. But we haven't tapped into that yet. Okay, all we're doing is energizing the coil at this point. So when I push this button, I should see the green light turn on, and I should hear this thing go click. Click, click, click,
Click.
The
Click.
sound effects are worth staying up for.
I got mine working. You need to see it. I'm pretty sure you probably do, right? Let me finish numbering.
Yeah, I'll need to see it. All right, so what are we going to do next? Oh, the next step here is if we're going to use this coil, if we're going to use this ice cube relay to switch things on and off. And do you remember why I said, what is the reason to use a control relay rather than just wiring that push button straight up to the light and whatever else? What do we use these for, relays?
Convenient.
They're convenient. Yeah, but you can use the main thing is you can use a smaller control voltage to control a bigger power voltage.
Right.
So if you're running think of a motor starter, right? A motor starter is a relay with overloads on it to protect the motor. If you're running a 480 volt motor, you can use 120 volt control voltage to pull in the coil and close those contacts. Let's say we're using this relay to, let's pretend that this is a 277 volt motor, okay? If you were gonna have like a push button that was able to handle 277 volts at whatever, let's say it was 15 amps for that motor, it might be a pretty big push button, right, to handle all that current and voltage.
Yeah.
And with this, we don't have to, because we can use this tiny little 24 volt coil to close the contacts that can handle that current and voltage. The other thing that is handy about these is we have, how many different sets? I think 4. Yeah, we have 4 different sets of contacts on this. And I'm looking at the ice cube. But you have a coil. So when that coil gets energized, you could have 4 different circuits that you're opening and closing, right? With one input. So from here on out, if I push this button and energize that coil, I could have 4 things that just turned on. I could have, I could be controlling another light. I could be controlling 2 different motors and a timer, let's say, right? Just by doing that.
And you could turn 4 different things off too.
Right. And that's the other part of it. You can turn 2 things on and 2 things off with this, right? Because you have normally open and normally closed sets. So just keep that in mind. Relays can be confusing for people, but for me, the more I hook them up and see them operate, the easier it is for me to understand. And I hope it's the same way for you guys.
Yep.
So we're going to see these, and we're also going to see our pretend motor starter down here pretty soon in the future. So what if we wanted to turn that on, and then when I let go of the button, it stays on? How do we do that?
You have to build in a seal-in circuit.
Seal-in. Some people call them seal-ins. I call them holding contacts, but they all do the same thing. So if you look at your ladder diagram, I'm going to move on to 5A. Okay, so here's my setup. And the only difference between mine and yours is mine has a different power circuit. So when I'm done talking here, I will upload labs 5 and 6 to the drive, and you guys can work on them whenever you want. But I'm going to go through 5A so you can see more realistic NEMA type industrial heavy duty setup here. So look at this. The circuit should look pretty familiar except for this right here. This little symbol, what is that called?
Control relay.
It's
Oh, no, the
associated with the
symbol.
control relay,
Oh,
but
the symbol.
yeah. I guess to be more specific, this. What does
Normally-
this mean?
Normally open.
It's a normally open set of contacts. If it was normally closed, it would look like this.
Okay.
Okay, but it's shown in its de-energized state like that, so that's a normally open set of contacts. Now what happens here is, in the previous example, when I let go of this push button, it opens back up, turns the light off, and turns the coil off, right? De-energizes the coil. What this allows us to do is, right now it's dead, so I have the potential voltage here and here. Right? So think of those wires as being live and nothing is energized. When I push that button, I get current flowing through the light. I get current flowing through the coil. And remember what a couple minutes ago I said that coil does to the contacts associated with it?
Mhm.
What does it do?
Close.
It changes the state of every contact on that coil. So every normally closed becomes open, every normally open becomes closed, which means since this CR1 normally open set of contacts is on that relay, it says CR1, so it's associated with this coil. This coil is energized, so it has made this now closed, which means current is flowing through here. So what happens if I let go of the push button?
It should stay closed.
It stays closed. That's why this is called a holding or sealing contact, because it keeps that thing energized. So let me back up to where it's a little less messy. I've just pushed this push button. This is closed, which means current is now flowing through here and here, right? I let go of the button, which means there's no current flowing through there, but the coil and the light are still energized. So, how do I kill it now?
Got to push the button again, or no, push the stop button.
Right? You push the stop button, opening this up, and it kills the circuit. So this is your basic stop-start circuit. You will use this a lot and a lot and a lot in classes to come. But this is your basic stop-start push button circuit with seal and contacts. So if I'm hooking this up on here, make sure I'm turned off here. Yeah. I'm going to go through my schmear here. Like I said that because it rhymes, schmear here. Do you like that, Nick?
Yeah.
Yeah. You just want to go sleep, don't you?
No. I laugh like this. I haven't laughed like this since I was a little schoolgirl. This is good.
Well, good, because that wasn't that long ago, was it?
No, it was.
Like yesterday?
Everybody enjoys cosplay nowadays. Yeah, we're good. Damn. Oh.
All right, so the first thing I need is, I need to number this. So I'm going to have you guys help me out here. What number is this?
That's a 1.
And this,
2,
this,
2.
2,
this,
3,
3,
3, 3, 3,
3,
this,
4,
4, this, and this,
4.
5.
4, right?
Yep.
Oh shoot, 4. Okay. Okay, I see it. Yeah.
All of these are connected, which means they're all going to be energized at the same time, right? They're all on the same potential.
I need to take a.
Okay, so I need a 1 coming from line 1 going to the stop, which I do. I need a 3 going from my stop to my start, which I do. This little jumper here. I need a 4 before I get too far. So I got 1 going to stop. I got 3 going from there to there. I also need a 3 to the normally open of my control relay. And I don't have that yet. So I'm going to slow down and zoom in on this control relay so you guys can see what's happening. So this is a pretty standard NEMA NEMA style control relay. Remind me tomorrow, I'll take one of these apart for you. Who's going to remind me? Who's in charge of reminding me of that tomorrow?
I'll tell you.
decent.
Okay, that's as good as I'm going to do. Right now, I've got wires hooked up to the coil. So on these type of relays, these are Allen Bradley Bulletin 700 relays. The nice thing about these is I can change these contacts to normally open or normally close, which is what I'm going to show you tomorrow. But do you see how this little part in here is the same as this one, but over here, these look different? The rivets look different.
Yeah.
That's because, and you got to get up pretty close to see the symbol on these. But these little tabs up here at the top show you a normally open or normally closed symbol. I'm going to look and see. I need normally open, and that's the 2 on the left are normally open. So these 2 are normally open. These 2 are normally closed. So when that coil gets energized, if you remember from the other day, you'd see this thing get pulled in like that when the coil gets energized, right?
Yep.
When that thing pulls in, these 2 close, these 2 open. And I can maybe, just maybe, show you with one of these things. It's true. So can you guys hear this? Can you
Yeah.
hear that? All right, so I'm gonna hold that on there. I'll be able to do that without actually. Okay, so I've got my meter hooked up to this normally open contact. So when this coil gets energized, which means I energize these wires, put 120 through that coil. It pulls this in and you get contact, right? So on my diagram, the ladder diagram, what I'm doing there is I push that button, I energize this coil, that pulls in and holds that coil closed so I can let go of that green button. And when I push the stop button, it will de-energize the coil and let go. Cool.
Yep.
Kinda, I guess.
Let me show you what I mean. On my ladder diagram, I need a wire number 3, either from the stop or the start, which is this. So I can go to either one of these locations and take a wire and run it up to the normally open, which is right here. I'm going to do that now.
So on ours, that would be 1 through 4.
What?
So on ours, that would be like 1 through 4 contact. Am I looking at this right?
Well, you have to look at your ice cube, right? I'm not
Right.
doing that right now. I'm doing the NEMA one. But on your ice cube, your normally open contacts, so you've got one set is 1, 5, and 9, right? So between 9 is going to be your common. If you run 9 to 1, that'd be normally closed. 9 to 5 would be normally open.
Okay. I think I got it. Let me see.
So I've got a wire number 3. Where's all my stuff at? Doesn't matter where I go from, where I come from, I just need a 3. I'm gonna go right there. One wire labeled on both ends, and then I can mark it off on my diagram. So there's a 3, there's a 3. Now I can go to my diagram and go boop. All right, on the 4 side, I need a 4 going from my start push button, which is here. So my start push button is here. I already have a 4 in there. It's going from start push button up to my coil. So I've got this, and I've got this done. I also need a 4 going to my green pilot light, which I do is this little jumper. So I can mark that one off. I just need a 4 going to the other side of my control relay normally open contact, which would be here. So I need a 4 right here. And the places I can pull them from are here, here, and here. What do you think the most logical place to put a 4 in there? Where's the most logical place to pull a 4 from? If I've got one here, here, and up here, and I need to go right here.
Probably from the top of the contactor.
Yeah, I just need a little jumper wire to go from here down to here. Am I making sense?
Yep.
So you did a jumper wire from, let me see. Um,
I got 4. Four going from the coil down to the other side of the normally open. So that would mean that this is done. I have a 4 there.
So for me, that would have been going from, okay, I'm lost.
Same place, Justin. From the coil on your Ice Cube relay, the number 4 wire you hooked up on the coil, you'd
Right.
hook that up. You'd hook it right up to one set of normally open contacts on the same relay.
Okay.
On here, the only thing you're adding is 2 wires, right? You need a 3 and you need a 4 going to
I got the
normally open
3.
set of contacts.
I got the
Right.
3 in there.
You got a 3 going to one side. So on this, where did you land it?
I landed it on the 5 and the 9.
You can't land a number 3 on the 5 and the 9.
I thought you said we needed it on the common and the normally closed or normally open.
You need a normally open set of contacts. So one set. So if you look at this first all the way on the left, and I'm
Right.
not gonna zoom in on it right now, but that set, you got a 1, 5, and a 9. So you can run that number 3 to either the 9 or the 5.
Okay.
If you're gonna use this set of contacts as normally open, you got to use 5 and 9. So one side of this is going to be on a 5, the other side is going to be on a 9. So where did you run your wire number 3 to?
Okay, so I'm gonna run it to the number 5.
So you ran a wire number 3 to 5,
Right.
okay, and landed it. Then the other side, you need a wire number 4 going to pin 9,
Okay.
okay? All right, so the last thing that I need to check over here is that my pilot light and my control relay coil both have a 2, and they both do. On the coil, it's right here. And on the pilot light, it's this little jumper wire in there. So I should be good to energize this.
So do I land them both on the number 1?
What?
Do I land both of the 3 and the 9 to the number 1? I don't do that, do I?
Can you just bear with me for a second?
Yeah, go ahead.
Let me finish this up.
Yeah. Go ahead.
So in this setup, what should happen with this ladder is I should push that button, energizes the coil. It should stay energized because I've got that seal in, running current through it back to the coil again. And if I let go of that, the green light and that coil should stay energized. So I'll push it. You see how it pulled in and this green light came on. And that seal in contact is now what's running current back through the coil and keeps that thing closed. So then to kill this circuit, I have to hit the stop button. Everybody see that? That's your basic stop start station. Start, stop. And you can see how you could use that to run a motor too, right? Right now, all we're doing is controlling a light. All right, well, for the next about 45 minutes, I'm just gonna sit here and do this. All right, let's go look at this now. I have this wired up for lab 4. So let's look at lab 5 with this. All right, so I'm gonna go through this how I would go through it if I'm doing it. All right, so what are my wire numbers? 1, 3. And I put them on all the locations I know that I need to run a wire to so that I don't forget. So that would make this a 4. 4, 4, 4, and then the load side of these two is going to be a 2, obviously. So I'll run through this and make sure, but I've got from stop, I got 24 volts going to the stop. That's my wire number 1. Change colors. This is done. From the stop to the start, that is this wire here. So I've got this and this. I need a 3 to go down to normally open CR1. So I need a 3 to come over here and land on which one of which 2 are we using? 9 and 5?
Yeah.
Is that what we decided?
Yes, sir.
Okay.
So that's going to be, I'm going to pull mine from here. This is a wire number 3. See, this is where it helps it if I had done wires. I went from 1 to stop, 3 from stop to start. So yeah, that's 3. Over to where? So 9 and 5 are these 2 screws, it looks like to me, right? Is that what you guys are seeing? Yes, no, maybe?
Hold on. Sorry.
I see 5 at the top.
These 2 are 9 and 5?
Yeah.
I'll take this one to 5 or 9 or whichever one this is. Got that one in there, which means on my ladder I can check this off. The other side of my start, I should have these 3 already. From the start to pilot light and control relay. So I've got 1 going to the green light. That's this one. The other one going over to the control relay coil. So those are 4s, so I can mark those off. And I just need a 4 going to the other side of this contact. So I've got a 4 right here. Why don't I just use it? I'm just going to put a little jumper wire from here over to here. Right?
Yeah, I was looking at that. If you use the coil side, 9's closest to the coil. So if you're gonna pull a 4 wire from the coil, you could just go straight to 9. It would be a real small jumper.
Right. So what Nick's saying is you running wire, that probably would have been better than what I'm doing, Nick. Thank you. This wire number 4 would have been easier just to run a little 4 from here to here. Since I ran my 4 to here, I have to go from here around to the top. Either way you do it, it's going to work. Nick's way would be prettier.
Yeah, that's where I got my 4 coming from the bottom. So
Good. So yours is going to be prettier. Get up in there.
oh, cool. That works.
You working?
Yeah. I guess you need to see it now. I'm assuming.
All right, so what should happen then with mine and with yours is I should push the button. It holds. And then if I push the stop, kill it. Okay, so for the next 20 minutes, I'm just going to do this. So everybody understands how that, the important thing is you understand how seal-ins work, holding contacts. That's what we should get out of today.
Okay.
Yeah, I
Running through
understand
these
that.
ladder diagrams is going to be this. I'm going to show you and tell you to do it the same way every single time. Start from the left, start your numbers, put one wire at a time, label both ends, mark it off on your ladder diagram, and then keep going.
Can you see my circuit?
Hang on, let me pin your video. Sort of. Can you just back the camera out and show me that it's working?
I think so. Is that backed out enough?
All I can see is your window.
You see me now?
Yeah, go ahead and just hit the start. Hit the stop. Sweet, good job. Now listen, Justin, the only thing that I would suggest, and just looking at yours right now, and it's hard to see, but try to be a little neater. Like use the C
Okay.
channel, that gray C channel. Don't be afraid to use an extra 6 inches of wire just to make it look neater. Because as these ladder diagrams get more and more complex, you're going to be glad that you made it look neater. It's not just for me to look at pretty things. It's like you're going to want to see some stuff routed in that channel in a more aesthetically pleasing way.
Okay, I got you.
All right. So that's
I
just,
think I
that'd be
think
my
I can-
only suggestion moving forward is to, you know, put a wire into contact, have it labeled, run it down into the C channel if you can, that gray stuff,
Yeah.
and then run it over to your next location. And cool.
Okay. I can try to do that now.
All right. Well, I'm going to upload labs 5 and 6 onto the shared drive. Oh, last thing before we, if any of you are going to take off, is on Blackboard. I made the next 2 assignments, chapters 4 and 5 homework due Thursday.
Okay.
And that we'll see how that pace works, doing, you know, the 2 chapters be due on every Thursday, and then the following Monday we'll take a quiz. And if that works for everybody, that should leave us plenty of time at the end to go over anything that's left over. And also, like, if we get through all the material, we'll just go ahead and take our final early.
Okay.
But that'll be our little secret. We're supposed to go to, I think, July 26th. But if everybody's understanding everything, we get through all the material, then we'll have a little barbecue or something.
Hell yeah.
Nick's hosting.
Decent.
Hell yeah.
We'll have to do it at midnight though, so Nick's actually awake.
That's that. At that time, yeah, that'd be great. Oh. All right. Who did you say is who makes that?
I want to say it's Daytona. Hang on, let me look. Oh, Den Nectars.
Okay.
DINNECTORS.
All right.
They're pretty sweet little things. They're not cheap, but
Yeah, if like the Phoenix Contact are real expensive, and so are the Allen Bradley. So I've been
they can
looking.
make them expensive because they're so freaking convenient, you know. And then they sell those little jumper stab-ins that go right in there,
Yeah,
you know. So instead of putting all these little jumper wires in, you just pop a few of those in.
and they've like the Phoenix Contact makes them where they're like 4 layers. So
All right,
instead-
guys, I gotta go. I have another meeting.
okay, have a
All
good
right,
one.
you too. You guys have a good one.
See you, Justin.
So I was gonna let you know, Zach. I had to work the last 3. I get 1 day off. I work the next 3, and then I'm taking vacation, so I'll have a full week off. I'm gonna do as much of the labs as I can, and then I'm gonna get caught up for sure after Thursday, if that's okay.
Okay. Yeah. Just yeah. Everything will be online for you to do if
Okay.
you have to miss, but I like it when you guys come as much as possible because then we have interaction. I don't just have to sit here and record myself doing crap.
I understand.
And
Um,
this type of stuff, like we need to be talking to each other. You know, I can't just show you how to do something and let you go work on your own. We need to be talking to each other. So
Okay. Yeah, no, that's fine. I'll try to catch up so that I can do it with you after